Welcome to The Explainer. Today, we are solving a really frustrating mystery in the world of AI. Why these incredibly powerful large language models have this one critical blind spot, and, more importantly, what you can do about it.
So let's set the scene, because I'm sure you've been here. You've spent weeks, maybe months, building a state-of-the-art retrieval augmented generation system. Your retriever? It's perfect. It goes out and finds the exact documents with the answer you need. You feed this beautiful context to the large language model, and it looks you dead in the eye and gives you a confidently, completely wrong answer.
If this sounds familiar, you are definitely not alone. This isn't just some random glitch. It's a consistent, well-documented issue, and it even has a name, the lost in the middle problem. The model had the evidence. It was right there, but it just ignored it.
Okay, so to really get to the bottom of what's going on, we have to look at the evidence. And the big breakthrough really came in 2023 from a paper by researchers at Stanford and UC Berkeley who decided to test this problem systematically. And what they found was this incredibly clear pattern. When they put the key piece of information right at the beginning of the context, the model's accuracy was great. When they stuck it at the very end, accuracy was also great. But the second they buried that answer anywhere in the middle, accuracy just falls off a cliff. What you get is this distinct U-shaped curve of performance. Now, this U-shape is actually caused by two cognitive biases that seem to be baked right into the models. On one side, you've got primacy bias. That's our tendency to remember the first thing we see. And on the other side, you've got recency bias, the tendency to remember the last thing you see. Everything else, all that stuff in between, is basically in a danger zone. And here's where it gets kind of wild. This isn't just a machine problem. We humans do the exact same thing. It's called the serial position effect. Think about it. If I give you a shopping list, which items are you most likely to remember? Yep, the first few and the last few. It's fascinating, right? The models have developed a cognitive quirk that is strikingly human.
So the big question is why? Why does this happen? Is it a bug in the code? An issue with the training data? Nope. The answer is actually much deeper. It's not a bug, it's a feature. One that's baked into the fundamental architecture of how these models work.
So let's put on our detective hats and investigate the two main culprits behind this. It all boils down to two things: how the model pays attention and how it understands order.
First up, causal attention masking. Okay, think of the context window like a one-way meeting. The very first word, or token, that speaks is heard and considered by every single token that comes after it. But a token in the middle? It's only seen by the tokens that follow. This structure just naturally gives those early tokens a huge advantage. They get way more attention, which creates that primacy bias.
The second culprit is something called positional encoding decay. Now, to understand the order of words, modern LLMs use this really clever system called ROPE, which basically gives each word a sort of positional timestamp. The problem is that signal gets weaker over distance. So for a word stuck in the middle, it's too far from the beginning and too far from the end for its position to be really clear. It ends up in this kind of attentional dead zone.
Okay, so we've diagnosed the problem. We know the architectural reasons why it happens. Now for the good part, the solution. And this is where we get to move from just a fascinating problem to some really practical, production-ready fixes. Because once you know this bias exists, you can totally use it to your advantage.
So here's the absolute key takeaway. The simplest, most powerful fix isn't some crazy new algorithm. It's to stop fighting the model's nature and start working with it. You just put your most important information right where you know the model is already looking.
So here's the new playbook in action. Your RAG system retrieves a set of documents. Don't just dump them into the model randomly. No, be strategic. You take your number one, most relevant document, and you put it right at the very beginning. Then you take your second most relevant document and stick it at the very, very end. All the less important stuff, let it fill up that dead zone in the middle.
And you have to remember this. More context is not always better. In fact, it's often much worse. Just jamming 20 documents into a prompt creates a huge, messy middle where the important facts can get lost. You gotta be surgical. Use a reranker. Find the top 3 to 5 absolutely critical documents and just use those.
Now, beyond just reordering, you have a few other tools in your toolbox. One is prompt compression. You can use an LLM to pre-process documents and pull out just the key facts. Another is just being direct. Add an instruction right in your prompt that tells the model to carefully consider all provided documents. And finally, if you need maximum accuracy, using a cross-encoder to re-rank your documents gives you that surgical precision to know what really is number 1 and number 2.
When you really internalize this lost-in-the-middle problem, it just fundamentally changes how you should be thinking about building any application on top of a large language model. The most important thing here is a total mindset shift. For years, we've been told bigger context windows are the holy grail. More is better. But the new rulebook is crystal clear. Structured context is better. The quality and, crucially, the arrangement of your data are way more important than just the raw quantity.
And this all leaves us with one final, pretty provocative thought. As we get better and better at designing our systems around these architectural quirks, putting the answer right where we know the model is going to look, are we really teaching these models to understand and to reason, or are we just getting incredibly good at building them the perfect cheat sheet? Thanks for watching.